Hi, everybody. I hope you're doing well. We're kind of switching. Hopefully, you'll enjoy this because we're not going to graph so much anymore. Although we are going to graph a couple things right off the beginning, but we're going to get away from the actual graphing and kind of go in reverse where we've got the graphs given and we're looking for the equation. And this can be a bit tricky, but unlike the other functions, you can kind of follow the same pattern, which is helpful. So once you do a few of these, it should be a bit easier. But before we do that, I just want to remind ourselves of sine and cosine graphs and look at a couple things. So hopefully at this point you know the sine and cosine graphs. So here is sine. Oops. It starts at 0 and goes up to 1 for a max and has a period of 360. If we go backwards, it looks like this every 90 degrees as long as the period hasn't been changed. So that's sine x. So cosine x, which is very similar, but starts instead at 1, goes down like that, and then if I repeat the pattern every 90 degrees, looks like this. So a couple distinctions between the two. Obviously cosine, we can consider it starts at its max. Whereas sine starts at 0. And more specifically, it starts at the midline of this function. So if you imagine the middle point vertically, so here's my vertical distance, the middle here is when I'm at y equals 0. So that's an important distinction. But really, if you were to take sine, and I'm just going to highlight it over here on the cosine, here is the sine version within the cos function, and that's really sine. And so there is a relationship, and I mentioned it before, but really, this is the same, like if I wanted an equation, I could get an equation that starts here for sine. So if I look, that's at 90 degrees. So that means that I could consider another equation. Instead of cosine, I could say y equals sine, and then it's been shifted to the left. So I have to say it's sine x plus 90 because it's the opposite operation. So this is the same, this is equivalent to cosine x. So that you can get two different equations based on that. And in fact, you can get a whole bunch of equations, and we'll go through that in a minute. So here's what we're going to try to do is, here is a graph that's given, and we're going to try to get the equation of it. So just remind ourselves, it's going to fall in this form of y equals a, sine or cos, doesn't matter, k bracket x minus d, and then plus c. So just a reminder, a is the amplitude. C, if I deal with the other thing that affects y, shifts it up and down. And then inside we have the things that affect x. So k is related to the period. It is not the period, but it's period equals 360 over k. And then this d, which I was just talking about, is the shift left and right. So if we can figure these things out independently, given the graph, then we can figure out the equation. So if you look at this one here, what we're going to try to do is write the equation in terms of both cosine and sine. So when I look at this function, notice it starts at 0 right at its max. So here's my max, and there's my min. So we're going to need to know that information. So if it starts at its max, like here, that is like cosine. So let's start with the cosine equation. So one thing we can get, and the order of this doesn't really matter, but if I have the max and min, I can get the amplitude, which is a. So if I take the max, which is 1, subtract the min, and then I divide it by 2, the min is -3. So that means that I get 4 over 2, which is just 2. So that automatically gives me the a value here. So done. The other part to get in terms of vertical is my midline. So you can either figure this out by doing half of the distance between the min and max, or you can just kind of eye it up, whatever you want. It's generally not too hard to figure out. And if I look here, it's at -1. So that's my midline. So I'm just going to label that. And so my midline is C. And that's pretty easy to get as long as you know what's going on. So that's -1. Okay, the other parts are a bit trickier, but not too bad. So one is the period. So we need to figure out the period. So remember that the period is equal to 360 over K. So we don't input the period directly into the equation. What we do is use this proportional relationship between 360 and K, and we input K into the equation. So if I highlight here, let me pick nice red. So if I want to follow along for one cycle, I'll get to the top of the cycle twice. So I've got this max and this max here. So what I want is that horizontal distance between them. So there's my period. It's a bit tricky here because of the scale. So I've got 90 degrees here, and there's 1, 2, 3, 4, 5, 6. There's 6 ticks there, so that means I gotta divide 90 by 6, just so you know that that's 15 degrees, so that makes this 30, and so on. So this would be 105, and then this would be 120. So it looks like my period is 120 degrees. So what I want to do is I want to change this around to follow this equation here in order to get K. So if I switch K and the period like that, and I know that my period is 120 degrees, then I just sub it in to get K. So therefore K is 3. So we've got pretty much everything we need. The only other thing would be D. And notice here, if cosine, and this is the tricky part, if cosine starts on your graph at 0 at the max, then that means that you haven't shifted and you're at the starting point. So therefore for cosine, D equals 0. So I'm just going to create my equation now for cosine. So I've got y equals, and I fill in the things, a was 2, cos, and you can put big brackets, it's not absolutely necessary, but I can put that in. And I have 3, and then I would have generally x minus d, but d is 0. So I don't really need that, but I'm going to put it in there just so you see it. And then I've got -1. So this could be simplified slightly without all those brackets. So I could have just 3x minus 1 like that. Not a big deal either way. So the next part is to get sine. What's nice is that once you have A, K, and C, they are the same for sine and cosine. The amplitude, the period, and the vertical shift doesn't change for sine and cosine. So I'm just going to write that in. A, K, and C are the same. So once you get those figured out, you don't have to do anything to do that for the second one. So here, what I do need though is I'm gonna need where it's been shifted. So this is where we have to think, okay, normally sine starts in the midline and then goes up like this. And so what I need to do is find on the graph where the midline is. So midline's at -1, so I've got to find that point where it then starts to go up like that. And that would be where sine would normally start. So if I was to follow one, let me just get rid of this red. If I was to follow along for one pattern here, I would start there and I would continue on until I get back to the midline there. So that would be like one period of sine. So what's important here is that I need to know how much it has shifted to the left to get to that starting point, and that's my D value. So if I look at this, we said this was 15 degrees, so this would be -30 degrees. So that means it's been shifted -30. So in my equation, I put +30 degrees. So overall, my equation will be y equals 2 sine 3, and then I put the x, and because I'm going left, I put +30, like that, and then -1. And so you can put that in. So you can check this on your calculator. if you want, you'll have to change your window settings. If you press window, and then there's a trig button that you can press that will give you a good range for or domain for that. Okay, let's try another one. So this one, again, similar, we're doing sine and cosine. So if you can, try this out yourself and see if you can get it, but otherwise you can just follow along. So I'm gonna start again with the max and the min. My max is 3, my min is -3, so my amplitude's pretty easy. I just have 3 minus minus 3 divided by 2, which is 3. That's pretty easy. And then that makes my midline just 0. So that's my midline. And so C is just going to be 0. Now, it's a bit harder here to figure out my period because it doesn't start right at 0 here. So I'm not going to pick that one. I'm going to start right here. And then I'm going to follow along because I know once I get back going up, when I hit the x-axis, I know that's where it's going to stop. So my period here, and this is a bit harder to figure out, looks like each tick is 30. So that means this must be -150. If I go along here, this would be positive 570, I think. Is that right? Yes. Yeah. So my period is going to be, let me just figure it out here. Period equals 570 minus 150. So I'm just adding them, so that's going to be 720, like that. So that's not so bad. So now again, I have to do a little calculation for K. So K is 360 divided by the period. So my K this time is a fraction, which makes sense because this thing's been stretched out horizontally so that it's, I need a fraction to make that happen, to increase the period. So that's that part. And then my D value for cosine starts at the top, so that's up here where the max was. So I've shifted to the right, again, that's in 30 degrees. So my D is going to be the opposite sign, which is -30. So that gives me everything I need. So I can plug them in. So I've got 3 cosine 1/2 x minus 30, and there is no vertical shift, so I can leave that blank. And then so sine, similarly with sine, this time only I'm going to shift, I need to start at the middle. So I'm shifting to the left, and that's 150 degrees. So my D here is going to be plus 150. So I've got the same A, so that's 3 sine, K is 1/2 x plus 150, and we said no C value. So if you follow along with these steps, it's not so bad, but it can be tricky depending on the question. So what I would do are these ones. So try them out yourself. I am going to take up the first one here because I think it gets a bit tricky. And just so you're aware, there are often, you could actually have an endless number of different versions of the equation because the shifting happens in every period. And so you could have a whole bunch of different equations. For this one, I'm going to show some options, but again, try this out if you can and see what you get. So it says write the two equations, one in this term, so notice it doesn't have a shift, and one with cosine where it does. So again, let's just take the things that are easy. So like if we want to find A, again, it's the max minus the min divided by 2. So that's 5 minus 1 over 2, which is 3. So that's nice and easy. My midline then, if I look at it, is going to be in the middle of that. So that's like going up 3 or down 3, depending if you're starting at the minimum or maximum. So my midline which is C, is going to be positive 2. And period, let me just switch here. So if I was to go all the way from here to here, it means, and I'll highlight that, if I go along, so that's my period. So that's going to take me to here, which looks like half of 90, so that's 45 degrees. My period is 45 degrees. So therefore my K, being 360 over my period, is going to be 8, if you punch that in. So my K is 8. And so in the first one here, they're saying don't include a shift. I am going to include a shift, and then I'm going to show you what it'd be without the shift. So normally sine starts at the middle, which it's doing here, except for it's going down, notice here. So that's not correct. But what is happening here, if I shift over to this point and go up, that does work. So therefore, I do have a D value if I consider it like that, where my D would be half of 45, which is 22.5. And I'm going right, so it's actually negative. So one version of your equation could be this. 3 sine k 8 x minus 22.5 and then plus 2. But notice here they've said don't have a shift. So one thing you can do, and this is an equivalent, this right here is correct, but not for what they've asked for. But so you could have another one where you actually start by going down. And the way to do that is to make this a reflection over the x-axis. In order to do that, you make the amplitude negative, or you change the A value. And so what that's going to do is, that means now I've started here right at the middle, but instead of going up, I'm going down. And that's what the negative here will do. And so I have the same equation, only I don't have a shift. So it would be like that. So again, that's a bit tricky. Both are correct, but given the parameters that they've asked for, the second one would be the one that you should have. So the other part to this is to get the cosine equation. And so remember, cosine starts at the top. So you could actually go back here, or you could go this way. Remember I said that you could often have different versions of your equation. So I could go back or I could go forward. So I'm going to do both. So again, A would be the same. So I'm going to stick with positive 3 cos 8. And then I got to figure out that shift. And this one's a bit tricky because we're into decimal, I think. So here was 22.5. So we're halfway between each of them. And so we need half of the 22.5. So the one to the left, this guy, is going to be plus, because it's going left, 11.25. That's half of 22.5. And then my shift is still the same, which is plus 2, I believe we said, yeah. So that's one version. If you took the second version, which is going to the right, it would be 3 cos 8 x minus, and then I would need to do 22.5 plus 11.25, which is 33.75, and then plus 2. So again, for me to mark these questions sometimes is tricky because you can have a whole bunch of different versions of it. But that's the idea. Hopefully that makes sense. So try out the rest if you haven't done them, and you can check